All right, so we've got a new foldable called Find Each Slope and Each Representation foldable. And today we're going to focus on the finding slope, which is m, the variable, from a graph today. So then what you see right here is what's on the top, on the outside of this foldable. And now we're going to look at what's on the inside and focus there. Okay, so I'm going to zoom in really closely here so everybody can see well there. So the first thing you're going to want to do is to identify two exact points, at least two exact points on this line where it's got a whole number ordered pair. Okay, so if they give you a line and they don't give you the points, that's where you're going to have to start. Okay, so what I'm going to do is I'm going to go through this line and try to identify where it's going through an exact whole number ordered pair point. Okay, so I see one, wow, right there. I'm going to make that dot a little bit smaller. And right there. And right there. Okay, so I've got about 3 dots there that I've identified that I could name those points. We've got 2, 5 here. We've got -1, 0 there, and -4, -5 right there. Okay, good. Now, what we do is we're going to draw right triangles connecting our dots, and then we're going to count the vertical side and the horizontal side, and we're going to write that as a ratio. Okay, so vertical side first, that helps me. If I draw the vertical side first, that will help me make sure that I put that as my numerator. And when I count 1, 2, 3, 4, 5, 5 is the vertical side. And I'm going to abbreviate 5 for V, vertical. And when I count the horizontal side, that's 3 horizontal. Okay, and let's see if it repeats that pattern. 1, 2, 3, 4, 5. 1, 2, 3. So I have 5 vertical again and 3 horizontal again. Now let's pretend that maybe you didn't see that one in the middle or something like that. Okay, you just didn't see it. And let's say you went from this point, which was -4, -5, all the way to 2, 5. Let's say you did that. Is that going to be a problem for us? Okay. And so when I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I've got 10 vertical this time. I'm going to abbreviate V for vertical. And then 1, 2, 3, 4, 5, 6 horizontal. Well, the good thing about this is that I can use any 2 points that I want. As long as I'm still on this line, I will still get the same slope. So we would write this as slope is 5:3 ratio. Okay? It's a ratio of vertical change to horizontal change. So let's write that down as steps in here. Okay? So first, if it doesn't give it to you, we're going to identify 2 exact, and I'm going to put whole number ordered pairs points on the line. Two exact points on the line that have whole number ordered pairs. Okay? Next, We started at the point on the left, okay? So that just helps me get the right things in the right places if I start on the left. Start at the point on the left. And we drew a vertical line first. And this is similar to what we did with Pythagorean theorem, tracing the vertical coordinate grid line. Okay, this will be the numerator, or the rise, or the y, the change in y. In the slope ratio. Okay, and I'm going to fix the font here so you guys can see all of this. So no, it's not letting you see it all, or right there. Okay, so we identified two exact whole number ordered pair points on the line. We started at the point on the left. We traced the vertical line of the grid, and then that number, once we count that number, that's going to be our rise, the numerator, and the ratio, the change in the y. All right, so then number 3, last up, we drew a horizontal line. Connecting to the second point on the right. We completed the right triangle. Okay, and the number is going to be the denominator, if you want to call it that, the x change, or the run in the slope ratio. Okay, those all have the same numbers there. Okay. So some other things that I want to tell you is it should be a repeatable pattern. If you get like what I had up here, we had 5/3. Notice I did not change that into a mixed number, so I'm going to tell you leave it improper. If you get an improper fraction, leave it improper. Compare your sign to the direction of the line. So what I'm telling you is watch out specifically for negative slopes. I'll have students that frequently get the numbers correct, but then they don't have the correct sign, which it matters, okay? And I showed you slope dude, so use slope dude if you need to use slope dude, okay? So I want to move on from there. So all of that, hopefully you guys can write better than I did and make it fit onto here, okay? And if you need me to draw you again, a positive slope will go up from left to right, and a negative slope will go down from left to right, okay? So all of that should fit, try to make it fit right here on the inside of that flap. So I want to take you to the next page here, finding slope from a graph. Slope is the vertical side of your right triangle, vertical change to your horizontal change, and you'll hear the words rise over run. So if that helps you get the right things in the right place, make sure you're counting the spaces and not the lines. And you can ask yourself about what would slope dude say, okay? So looking at this first example that we have here, all right, they didn't give us the ordered pairs. They didn't give us a point. So it looks like to me, it goes here, here, and there. So if I start on the left, draw my vertical side first, then my horizontal side, and I can repeat it, and that's important. If it's not repeatable, then that's not the slope. And I notice that my vertical side is a -1, and I like to put a V here to remind me to put vertical as the numerator. 3 is the horizontal side there. Okay, look at this one. I can't draw a triangle out of this. Like, there is no up-down business to this. So this is one you need to be able to look at and know this is zero slope. All right, this one, drawing the triangles, it looks like right here, it goes through this point. Let's use a darker color. That point, thinking that point, and that point. Okay, so I've got enough there. I've got a repeatable pattern. I draw the vertical side first. I start on the left, draw the vertical side first. I'm going to make this pen a little bit thinner. The vertical side here is 3, the horizontal side is 1. And that pattern repeats. So it's 3 vertical to 1 horizontal. It is acceptable and encouraged right here. You can write that as the whole number 3. Okay, you got 1 as the denominator. That is a whole number 3 slope. All right, and then looking at this one, I can't draw a triangle out of this. It's just a vertical line. So when it's a vertical line, you should know this is an undefined slope. I'd like to add one more thing to this page. So where you have glued this page in, I'd like you to add 2 sentences, okay? And these 2 sentences have to deal with comparing slopes, okay? So the farther the slope is from 0. So really what we're talking about here is absolute value. The more steep the line. Okay, the line is more steep. And inversely, the closer the line is, or excuse me, the slope is to 0. And again, we're talking about absolute value. The less steep the line is. Okay, so let's go back and look at our examples here. Look at the one on the top left. I have a -1/3 slope. So if I change that to a decimal, as a decimal, this would be -0.3. Okay, look at how that line is not super steep. Now on the flip side, see, this is a fraction and it's less than 1. So it's not very steep in its absolute value. Now look at this line. This line had a slope of 3. So look at the rise there. Look at, it's 3 for the rise and 1 for the run. This is farther away from 0, the 3. So 3, if I compared it to -1/3, 3 is a more steep slope. 3 has more absolute value than 1/3. So 3 is more steep when I graph that line. Okay, so there you go. Farther the slope is from 0 in its absolute value, the line is going to be more steep. And if the line, the slope, has a smaller absolute value, then that line is going to be less steep. Okay? Thanks for watching.